Okay, so now that we read through that example, we know that we're going to use this equation right here. I forgot to ask earlier, though, what is E? It's a number, right? Okay, so it's a number, so that's why we don't have to worry about it in our variables. Now, what are we after?
The exponential growth.
We're after the exponential growth function, so we're looking for the equation. So in order to find the equation, we need to find all the variables. In particular, because one they're not going to give me, is I need to find K.
Which is the rate in which something is occurring.
All right, so let's go through it. So I have A. What did you tell me A represented? The ending amount. Do I know an ending amount of this population?
Yes. 1052 million.
The 1052. Good. Million. Equals, do I know a beginning amount of that population?
Yes. 807.
E is a number. When you don't know K, how much time did it take for it to go from 807 to 1052?
11 years.
How'd you get 11 years?
From 2000 to 2011.
From 2000 to 2011. You could just subtract it, right? All right, good. So now we just need to solve for K. But where's K at?
And the exponent.
All right, so we got to get this exponential piece by itself. What do we do?
K times 11 log.
Not yet. Got to get that part by itself first. I've got that 807 over there. What am I going to do with it?
Divide.
Divide it. So divide both sides by 807. So we got 1052 divided by 807. Go ahead and round it to 3 decimal places.
1.303.
Okay, 1.304 rounded correctly, right? And K times 11, I'm just going to rewrite as 11K. Now, how do we get a variable out of an exponent?
Can you log it?
You're going to have to log both sides. And since I have an E, what kind of log are we going to use?
Natural.
The natural log. So we're going to take the natural log of 1.304, and that's equal to the natural log of E raised to the 11K. Now what do we do? Okay, yeah, we're going to move that 11K in front of its log. And so I'm going to rewrite that up here at the top. So we got that natural log of 1.304 equals 11K natural log of E. Anybody remember what the natural log of E is?
Is it 2.87?
No, E is 2 point something. What is the natural log of E? It's 1. Okay, natural log of E is 1. So 11K times 1 is what? 11K. So we don't actually have to write the natural log of E then. So anytime you have just natural log of E, you can go ahead and cancel it out if it's being multiplied because it's equal to 1. And anything times 1 is itself. So what do we do now?
Get the natural log of 1.304.
Well, you could.
By itself, divide by 11.
Go ahead. I'm going to go ahead and divide by 11. But yeah, you could have done the natural log of 1.304 and then divided by 11. Either way will work.
You have to solve for.
And then go ahead and solve for K. So what is the natural log of 1.304 divided by 11?
0.024.
And it told me to write the equation. So in my equation, I'm going to plug in K, but I'm going to leave A and T by itself because we know a beginning amount. They told me, didn't they? So we're going to leave is A equals your beginning amount, the 807, times E raised to your K, and then the letter T. Because this way, it doesn't matter how many years have passed, we could find, if we wanted to, we could find, according to this model, what we believe the population in Africa would be then in this year, 2018. So that way we could plug in a t and we'll solve for our a. So there's my equation.